Today we're analyzing graphs of polynomial functions. So your essential question is, how do I write an equation for a polynomial function just by looking at the graph? So first, we have a few things to talk about. When we talk about the multiplicity of a solution, that is how many times a solution is repeated. So for example, if I have the function x minus 4 cubed, really that's saying x minus 4 times x minus 4 times x minus 4. So if I set those equal to 0 to find the zeros or the solutions, then I would get 4 as a solution 3 times. So it would have a multiplicity of 3. So when we talk about multiplicity, it's how many times a solution is repeated. Now, this is really important, and we'll kind of go more in depth to this in a minute. But on a graph, if a 0 touches the x-axis, then it has an even multiplicity. So the exponent that would be attached to it would be an even number. So for example, if I was drawing a graph and I had a 0 that looked like this, or a graph that looked like this, and this 0 right here just touches the x-axis. It bounces off of it. It doesn't cross all the way through it. So if this, let's say this was -2, then this 0 right here, if the 0 is -2, then that would mean that the factor that's associated with that would be x plus 2. And so when I'm writing my equation, the number that's associated would have to be an even number, such as 4. Okay? If the 0 crosses the x-axis, then it is an odd multiplicity. So if it crosses, it has an odd multiplicity. So this 0 right here, let's say this is +2 and this is +4. Then since it crosses through this one and it crosses through this one, both of these would have all odd multiplicities. So they would have, like, if the 0 is 2, then that would be x minus 2 would be the factor, and x minus 4 would be the other factor, and both of these would have an odd multiplicity. So they could have a multiplicity of 1 or like 3, any of those, okay? Now, let's go over our end behaviors again really quickly, just to remind you of what these graphs would look like. So if the degree is odd and the leading coefficient is positive, then the end behaviors would look something like this. Okay, it'd be like a snake, and it would go down on the left and up on the right, and it can do as many little curvy things in the middle as it wants. That would be something like x to the 3rd power plus 3x. This function would have an odd degree, and the leading coefficient would be 1, and it's positive. Now, if the degree is odd and the leading coefficient is negative, then the graph would look backwards. It would go the other way. It's still a snake, but it goes up on the left and down on the right. So for instance, that would be something like f of x equals -3 x to the 3rd minus 2x squared, or 2x plus 1. So it has an odd degree, negative leading coefficient. And then even degree would be if it goes up on both sides. If it's positive and even, it would go something like this. It could be a parabola. It can do as many curvy things in the middle as it wants, but the end behaviors would be up on both sides of the graph. And that would be something like f of x equals x to the 6 plus 1. Something like that. And then I forgot, I think, oh, yep, if the degree is even but the leading coefficient is negative, then remember that means that it would look something like this. It would be down on both ends. So it would do something weird and then be down on both ends like that. And that would be something like the function f of x equals -x to the 4th plus 3x minus 2. I don't know, something like that. Okay, so just to review those before we start this. Now, this says graph each function without using a grapher. Now, this is actually a problem from the worksheet that you guys are doing today in class. So you can go ahead and get your worksheet out and do this with me at the same time. This is number 2 Okay, the easiest way to graph a function without using a grapher is to check the end behavior and just plug in some numbers. So if I just make a quick little chart here, and I'm plugging in -1, 0, and 1. Okay, well, if -1 to the 4th power, if I plug that into my calculator or just think about it, -1 times -1 times -1 times -1 is going to turn out to be +1. Then 0 to the 4th power would just be 0. And then 1 to the 4th power would just be 1. And you can plug in more numbers if you want, but basically if we just sketched a quick graph of what that would look like, it would be something like this. And so it just makes a parabola. Okay? Number 4 is a different example. We can do the same thing though. Oh, and we forgot to check our end behaviors on the last one. Let's go back to that really quick. Since it has a even degree and a positive leading coefficient of 1, it should be up on both ends, which it is. Now this one is an odd degree and a positive leading coefficient, so it should look something like this. It should be down on the left and up on the right. And we can plug in the same numbers we plugged in last time. So if we have -1 to the 3rd power, that would be -1 times -1 times -1, so it would come out to be negative. And then 0 to the 3rd power would just be 0. And 1 to the 3rd power would just be 1. So this time, if we sketch our graph of this, we have -1, -1, 0, 0, and 1, 1. So it would be like this. Down on the left, up on the right. Okay, now let's get into our multiplicities and graphing and all that. Now we're sketching these graphs without a graphing calculator. And it says to clearly mark the zeros and state its multiplicity. Now, I also did not mention yet that the degree is equal to all of these exponents of these solutions added together. So for instance, since these don't have one written, technically all of these would have an exponent of 1. So the degree would be equal 3. And we notice that there's a negative in the front, so the leading coefficient is negative. So if we just kind of think about what that's going to look like, thinking about end behavior, the degree is odd and the leading coefficient is negative, so it should look something like this. And I always sketch a picture of that first so that I don't have to think about it later. So then these factors, since it's in factored form, this gives us all the zeros of the function. So this, if we set all of these equal to 0, -x equals 0, x minus 2 equals 0, and x plus 1 equals 0, that will give us our zeros. So this we would divide by -1, x equals 0. This one we would add 2, x equals 2. This one we would subtract 1, x equals 1. And you may be able to do all that in your head, so you don't have to show those over here. But if you don't remember, then you can always just set it to equal to 0 and check. So we know that our zeros are going to be 0, 2, and, oops, that should be -1. -1 and 2. So I'm going to mark all of those on my graph and see what they're supposed to do. Now I know the end behavior is supposed to be up on the left and down on the right. And then remember how we talked about if the 0 crosses through the x-axis or if it just touches the x-axis. Well, all of these degrees, all of these multiplicities, I mean, are odd. So if it's odd, does it cross the x-axis or touch the x-axis? The correct answer is it crosses. So this one's, the 0 is going to cross. I'm going to put a little 0 there, or C there for that. The 2 is going to cross, and the -1 is going to cross. So this means that it has to go up on the left, so it has to start up. It has to cross through this one, cross through this one, and cross through this one, and go back down on the right. So when you're thinking about it, if it crosses through, you just cross through and then come back up, cross through, come back down, cross through. So you have to think about if it's odd or even multiplicity and see if it's supposed to cross the x-axis or touch the x-axis at the 0. And then you also have to think about the end behavior. So let's try another example. What would be the degree of this polynomial function? This time we have 3, 2, and 1. So that gives us a total degree of 3, 4, 5, 6. And then we need to look at the leading coefficient and see if it's positive or negative. There's not a negative sign in the front, so it is positive. So our degree is even, and our leading coefficient is positive. So that means the end behavior is going to be something like this. It's going to go up on both ends, and it can do whatever we want in the middle, but the ends are both on up both ends. So if we sketch the graph of this, what would be the zeros? Okay, well, if I set this one equal to 0, I have 1. If I set this one equal to 0, I have negative 4. And if I set this one equal to 0, I have positive 2. So I'm going to put all of those on the graph. So negative 4, positive 1, and positive 2. Then we have to check to see if it's supposed to cross the x-axis or touch the x-axis. So this one is odd, so it crosses at this one. This one is even, so it touches at this one. And this one is odd, so it also crosses at this one. And the end behavior is up on both ends, so it has to be up on this side and up on this side. So I'm going to start up here. I'm going to touch, which means I have to bounce back up. Then I'm going to cross, and then I'm going to cross. And feel free to pause and go back and rewatch these if you're not catching this right away. It's okay. It takes a lot of practice. Okay, now let's switch to the back side, and we're going to look at number 16. So this is kind of a different example. This one says determine an equation for the polynomial graph pictured below. So for this one, if I look at my end behavior, we look at it and it goes down on the left and up on the right, which means that it would have an odd degree, which they already gave us, and the leading coefficient is positive. Now this is important to pay attention to, because if it was to go the other direction, like some of these other ones do on your worksheet, or if it was to go down on both ends, then the leading coefficient would be negative, and so you would have to put a negative sign in front of your equation. So make sure you look for those on the worksheet, and you can check the answer key to make sure you've got these right. So we're going to write a polynomial function, so we're going to have f of x equals, okay, we have to look for our zeros. Okay, so our zeros are at negative 3 and 1, 2, 3, 4, 5, 6, 7, positive 7. So what are the factors that are associated with those zeros? Well, we would have x plus 3, and we would have x minus 7. So we write our factors out first. Now we know our degree is 5, and so these multiplicities of these two factors have to add to be 5. So you have to pick two numbers that add to be 5. So it could be like 1 and 4, or 2 and 3. It could be a lot of different things. So we have to check to see what they should be. So this one, it crosses through this one. So that would mean that it has to be an odd number. So this one has to be an odd multiplicity. And this one just touches and bounces back up. So this one would have to have an even multiplicity. Now here's the thing. Technically, this one could have two possible answers because they have to add to be 5. So I have to have an odd number and an even number that add to be 5. Well, guess what? 1 and 4 would work, and 2 and 3 would also work. So technically, you could have this one be a 1 and this one be a 4. Or you could have this one be a 3 and this one be a 2. So I would accept either of those answers for this one just because we aren't for sure and we're just sketching a picture. But on most of the ones on the worksheet, there will just be one correct answer. So you shouldn't run into too many of these on the worksheet. Now, just make sure you guys go back and answer the essential question and write your summary. Thank you.